what is happening in A? Go ahead, Luz. Adding 5. So what is your next term?
29.
Perfect. Good. All right, B, what's happening? Go ahead, Isabel. Good. Excellent. All right, and C. Go ahead. What are we doing? Good. Multiply by 3. So what's your next term? 27. Excellent. So again, really straightforward. You know how to figure out the pattern. You're either adding or subtracting, multiplying, dividing, but instead of dividing, we're now saying multiplying. Okay? If you turn to the next page, okay, just this first one, they're telling you it's geometric. So what should you have? You're multiplying by the same number, right? What is that called? Growth factor or common ratio. Excellent. So what would it be here? Good. So we're multiplying by 1/3. Therefore, the growth factor is 1/3. Okay. All right. Or the common ratio. So now, a new term, which some of you already know this, okay, or have seen it or heard it before. The sequence below is arithmetic. What is the difference from what we just saw above? What are they doing here? Go ahead, Addie. Good. So it's adding or subtracting. Which one is happening here? Good. You're adding 5 to, and we want to include this previous term. So you're adding 5 to the previous term. Above, you're multiplying by 1/3 from the previous term. Okay? Should be from. Okay. So arithmetic. The word we're going to look for. Phrase. Words. Common difference. Okay? Common difference. Here, you can either add or subtract by the same number. So that's a big difference. Okay? Geometric, you'll be multiplying the previous term by the same number. Arithmetic, you're adding or subtracting the previous term by the same number, which is called a common difference. So on the first page here that we started with, how would we classify? What would A be? Arithmetic or geometric? Okay, good. And the common difference is 5. Okay, plus 5. B and C are both what? Geometric. Which has a growth factor of 1/2. This one is geometric. The growth factor is 3. Okay, so the ones we did on the warm-up then, B and D are both what? Arithmetic, right? We have common difference of 124. So you're subtracting 124. And then we have adding 19. Okay? So that is the difference between geometric and arithmetic. Okay? So we're going to see those throughout. And you have to determine which one's which. Okay? And what the common ratio is or the common difference. All right? So with your partner, I want you to classify and explain A, B, and C. Okay? Classify or explain A, classify and explain A, B, and C. with your partner. Go ahead. All right. In A, what is happening? Is there common difference, common ratio? Nothing. Michael? So there's no, you're not adding by the same number, you're not subtracting by the same number, you're not multiplying by the same number. Therefore, it would be neither. What's happening in B? Answer. Good. Subtract 12. Therefore, it's arithmetic. Awesome. So your common difference would be 12. Okay? Negative 12. So how about C? Julia? Good. So your common ratio or growth factor is 1/6. Excellent. How many of you did get that? A lot of you did as I was walking around. Awesome. So that's going to be big takeaway today. We are going to learn how to, given a previous term, how to write a rule, not an equation though, a rule to get the next term in line, okay? Which we'll get there first. But we have to remember, in order to get to that point, how to do function notation, okay? Here's the function you are working with your partner. Complete A through E. It's a little different. Some of them can be a little tricky. A through E. All right, let's go through function notation. Okay, we have f of n equals 3n minus 7. So for the first one, f of 10, what does that mean? What are we doing? What does that mean? Lucy?
Multiplying 3 times 10 because the f is still 3.
Okay, so we're substituting 10 in for n. Okay, so we do get the correct answer for A. 30 minus 7 gives you 23. Now B was f of 10 we already found. 23 minus 1 gives us the 22. Okay, any questions about those two? We're good? Okay, now for C, we have f of 10 minus 1. What did you have to do? This is correct. What did you have to do? Yeah.
Multiply 10 minus 1.
Okay, so 10 minus 1 is what? 9. So then we're finding f of 9, which ends up being 3 times 9, which is 27, minus 7, gives you 20. Okay? Then for D, the correct answer is 3. Okay? You had to find f of 5 first, which was what? F of 5 in total. So 15 minus 7 is 8. Then it's okay. F of 4 would be what? 5, and that's how you get 3. Okay? And the last one, we have f of n equals 23. What is the difference here? What are we solving for? Yeah, Anton. N, which is 10. Excellent. How many of you did get function notation correct? Hopefully. Okay, good. All right, so our next activity, okay, and we will see function notation in a little bit. Again, come back to it. So for activity 1, here are the values of the first 5 terms of 3 sequences. We have A, B, and C. For each sequence, describe how you get the next term. If the pattern continues, which sequence has the second greatest value for the last term? Which of these could be geometric? Okay, and how do you know? Elena says that it's not possible to have a sequence of numbers that is both arithmetic and geometric. Do you agree? Okay, So with your partner, go through this first activity. Go ahead. This one. All right, let's see what we got. So in A, what is happening? Add 10. Excellent. Add 10. 80, 90, 100, 10, 120. So if we're adding, what type of sequence is this? Arithmetic. Good. How about B? What's happening here? You're right. You're getting there. Okay. 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 Good. All right. I'm liking it. Yeah. Yeah. Exactly. Which is what all three of you were getting at, right? So in between, you have add 5, but then you have plus 10, so on and so forth. So you're adding 5 to what you previously added, okay? So after 50, what's my next? What's happening? Go ahead, Mia. 75, then what? 105, then? Good? Good? Perfect, guys. Perfect. Excellent. And then what is happening in C? What's that? Julia, go ahead. Multiplying by 2. Okay, so which one would this be? Arithmetic or geometric? Geometric, good. So after 16, what do we have? Excellent. Good job. All right. So if the pattern continues, which sequence has the second greatest value for the 10th term? B. Good. Okay. Which of these could be geometric? We already talked about it. Is C, because you have a growth factor of 2. Good. Excellent. All right. This one. Lena says that it's not possible to have a sequence of numbers that is both arithmetic and geometric. Do you agree? Explain your reasoning. Yeah, Michael. You agree? Okay, why? Mm-hmm. 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 Okay. Okay. Yeah, Luce.
I agree, but like I was thinking if it's like 1 times 1, like the
So, do you have an example of a sequence? You're on it.
it was on the homework. If if like each number is for less than 3 times the number, you could do like, or
Oh, it's okay. It's okay.
um
Okay. You're on. Yeah, Jonah. Okay, so what would be an example? So, an example of a sequence that can do both, okay? 1, 1, 1, 1. It is a sequence. It is a list of numbers. So, it can be arithmetic by adding 0. That's how you would become arithmetic, right? Geometric, you would multiply by 1. Okay? to be geometric. It would be the same thing. So this particular case, this sequence, it can happen, okay, where you are both arithmetic and geometric, have a common difference, and also have a common ratio. Okay, does that make sense? So 1 plus 0 gives you 1, 1 plus 0 gives you 1. It's the same number all the way through. Then for geometric, 1 times 1 gives you 1, times 1 gives you 1. Same number, which is your common ratio. Okay? Questions, comments, concerns? All right. We'll do this one together to make it kind of go faster. Okay? Read it through. Okay? Read it through, and they're giving you a chart here. It says it's geometric. Let's read it through. Who do we agree with? Yeah. Yes, you may. Go ahead. What do we think? Who do we agree with? Yeah.
I agree with mine
Mhm.
because the team number it changes. It's not going up by one still. It goes from going up by one to going up by three.
So are we missing?
We're missing two. No, we're missing three.
We're missing some term numbers, right? So by looking at it, we could say you are correct, by the way. Jada thought it was geometric because she was ignoring this term number column, right? And by looking at the value, it seems geometric by multiplying by 3, right? But there's terms missing, right? So if we included those terms, which you need those term numbers in order to distinguish what the sequence is, it would be arithmetic because what is it going up by? Can we figure it out? 4, right? So 2 plus 4 is 6, 10, 14, and then 18. So this also goes for you guys. If you're given a sequence, okay, and there are terms missing, just don't look at the values, okay? Look at if we have every term previously included, okay? So we must have definitely term 1 will most likely always be given to you, and in most cases term 2. But if you continue with the chart, make sure your other terms are there as well, okay? So, it's correct as Jada forgot about. And again, whatever you guys explain, term, and it just term 3 and 4. Okay, a little disconnection there, no problem. All right. So Jada forgot about the term 3 and 4 to complete the sequence. All right. So now, this last part. Okay, you have 500, 100, and then 20. Okay. Explain why this sequence can be geometric. We should know this no-brainer, Isabel. You're multiplying by 1/5. So our growth factor is 1/5. What would be our next term? Yeah, 4. Excellent. Good. So again, growth factor is 1/5. Next term would be 4. Good. This is frozen. Okay. So now, you guys, you might have 3 and 6 on yours. Cross it out to 2 and 8. Okay. So now, you're going to start with the same 2 and 8. find the next two terms of the arithmetic sequence, find the next two terms of the geometric, and then you have one that is neither geometric or arithmetic. Okay? Take a minute. Artboard issue. Okay, for number 1, what is my arithmetic sequence? We have 2, 8, and then what? Yep. 14 and 20, what did you do? Added 6, good. For number 2, what's your geometric? 2 and 8, and then what? 32, and what did you do? Multiply by 4, excellent. And then the last one was neither geometric or arithmetic, so there was no pattern happening, right? You could figure out a pattern that's not multiplying by the same number, adding or subtracting by the same number. We have 2, 8. What are some options? What did you guys get? Yeah, Ellery. 20 and 24. Good. Anybody else? Yeah. Good. Okay. Anything else? Right? It could have been anything, right? No pattern. Were you going to say 44 as well? Yeah. No pattern whatsoever. You could have multiplied it, then add by something. You guys could have came up with your own rule. All right? So, geometric needs what in common? What has to be the same for geometric? Growth factor. For arithmetic, what has to be the same? Common difference. Awesome. Turn to the next page. There's some phones missing up here, too. All right. Let's see. My smart bird's not working, so. How many of you have bowled before? Okay. All right. So, describe how to produce one step of the pattern from the previous step. Okay? So here we have step 1, step 2, step 3, step 4. How do they come up with that? Jot some notes down to the side. How do they come up with that? What do you notice about each step? What are some things you notice? Jot that down. Okay. What do you guys notice? Go ahead, Julie. Okay. Any similarities that you notice? Is there anything that you could kind of connect to? Anything? The step number compared to anything? Yeah. Right, exactly what Julia said too before. And if you look at the last row of each, right, is the actual step number, right? But you guys are right. You're adding the step number to the previous term, all right? So now consider the numbers of dots, d of n, okay, is a function of the step number, which is n. What values make sense for n in this situation? So if n represents the step number, what values of n will make sense? What values of n will not make sense? Think about it. What values of n make sense, which represents the step number? Which values of n do not make sense? Go ahead, Isabel. Okay. Okay. What else? What are the values that will make sense to represent n? Think of function notation in general. So if we go back to that problem, plus 7 or minus 7, I can't remember. Minus 7. What values of n would make sense? What can I input to n that would make sense? Yeah. A whole number. Is that the same regarding steps? Right. So for n, what would make sense are whole numbers. Are whole numbers. 1, 2, 3, 4, so on. What would not make sense in terms of steps? What are some values that would not make sense to use in this situation? Yeah. Good. Okay. So that will not make sense. Fractions, decimals. Anything else? Those two are correct so far. Anything else? Yeah, answer.
Maybe for this one, negative numbers.
Negative numbers, which was said, I think, before too. Okay. What else? Think of all the math terms, all numbers and terms you've learned. What else would not make sense? Pi wouldn't make sense, right? Okay. Wouldn't make sense. Radicals wouldn't make sense. All right. So when you're talking about n referring to the number of steps, whole numbers is your best bet for now. Okay. According to this problem. Now, if we look at the table below, this goes along with coming up with the pattern. So we see for n represents your step number. Step 1, the result was 1 dot, right? Step 2, the result was 3 dots. Step 3, the result was 6. Okay? Step 4 would be how many? You see it right in front of you. What would it be? 10, okay? So how do I go from, how can I write, if I'm going from 3 to 6 to now 10? How would I write that? It goes along with what Julia said earlier about what is happening with these dots. So how would I write it here? What would I say? I want it to equal 10. Well, how can I display that? Number n represents step number. Yeah. 3 plus 4 equals 10. Awesome. Okay. How would I write for n is 5? Julia?
4
Plus 5 equals what? 15. Good. Okay. Awesome. All right. So how can I describe that? How can I describe that? What you both figured out. Following the pattern of a table, write an equation or rule for d of n in terms of the previous step. Be prepared to explain your reasoning. So how can I show, with not really including 2 or 3, the numbers here, how can I show that as an equation? Think about it for a minute. Discuss with your partner. Come up with something. Come up with something. Remember, N is your step number. Think in this class. Okay, so remember, N represents the step. D of N is the total number of dots. So we're creating a function. We have D of N. Okay? Now what? Go ahead, Addie. Got it?
Yeah, so it's like it's like a function of n minus 1.
Why, before you continue?
Because it has to be like the step before it. So like for like where it says d of 1,
Mm-hmm.
it's 2 minus 1. And then you have
Excellent. Okay, so what they just came up with is, remember, N represents the step number. Okay, so for example, if we look at our step numbers 3, okay, 3 minus 1 is 2. So that means how many dots were in the previous step? 3. Plus N, which is your step number, which is 3. 3 plus 3 gives you 6, which is your current total of dots. Does that make sense? See some of you trying to process that. Okay, so let's start here. Okay, 2 is probably easier to figure out. Step 2. So I know this is going to be 2, so everywhere I see N, okay, D represents the number of dots. Okay, number of dots. So 2 minus 1 gives you D of 1. So how many dots were in step 1? 1, right? And then our current step number is 2. So that gives you the 1 plus 2, which is 3. Does that make sense? Okay. So what you came up with was something called a recursive definition. Okay. A recursive definition, which is okay, a recursive definition just means that you're finding a new number based off of the previous term. Okay? So you need the previous term in order to find your current number. Okay? That's all, your current term. It's not so much a formula or an equation to remember, it's the recursive rule is you're using this to find your current value or your current term. Yeah.
so to decrease the previous amount of dots. Step or it's step 4, like how does that work?
Okay. So we have D of, say we're looking for step 4, right? Okay. So 4 minus 1 plus 4. All right. So 4 minus 1 is 3. How many dots were in step 3? 6, and then 6 plus our new step, which is 10. Okay, so you need the previous value, previous term, in order to find your new term. Make sense? Okay, so is this rule, so 1, 3, 6, 10, 15, is it arithmetic and or geometric? No, right? It's neither. Okay, it's just a recursive rule. All right, so if you turn to the next page, just to kind of close this all out, because I know we were ending pretty soon. Where you see R here, cross out difference, and it should be what? Ratio. Excellent. Good job. Okay. So like the first one here. We have 30, 40, 50, 60, 70, right? What type of sequence is that? Arithmetic, because what's happening? Adding 10 each time. So, we know our first term, a of 1, equals 30. Our common difference is plus 10. So how you write a recursive rule, and I'm just showing you this, would be n minus 1 plus 10. Okay? So when you write a recursive rule, okay, this just represents the previous term plus your common difference or multiplied by your common ratio. Okay? We will continue with that next class on Monday. Okay? Your homework.